Hello everyone, welcome on Tips Engineer Zone. We are going to learn about MB and LV capacitor testing and production online course. Okay, this is the develop practical skill in capacitor testing and production. Okay, welcome on Tips Engineer Zone. So we are going to see the course overview and objectives. So course overview is target audience. The course is designed for electrical engineer, technicians, and professional in power system and manufacturing sector. Okay, so this course is comprehensive insight into MB and LV capacitor design, manufacturing, and testing procedure aligned with ICA standards. So this is the practical skill development. Hand-on skill include capacitor assembly, impregnation, loss measurement, capacitance, and partial discharge testing. So quality and safety focus is emphasis on maintaining capacitor quality, reliability, adherence to safety and quality management standards. So course objective is understanding capacitors. Participant will learn the working principle and construction of medium and low voltage capacitors. And production stage, complete production process from material section to final product testing will be covered. And testing and standard is perform electrical and mechanical tests as per IC and IS standards and ensuring quality and reliability. And safety and quality management is apply safety quality measurement systems and Q and QC concept during capacitor manufacturing and testings. Capacitor fundamentals and classifications. Basic of capacitance and dielectric materials. Definition of capacitance. Capacitance is the ability to store electrical energy in an electric field between two conducting plates separated by a dielectrics. And capacitance formula is C equal to epsilon R A by D, involving permittivity, plate area, and distance between plates. And dielectric materials, common dielectric includes propylene and PET, paper oil composites, and gas types, and chosen for high dielectric strength and stabilities. Now, classification and applications. Features: rated voltage up to 1 kV means low voltage, and up to 1 kV to 36 kV is medium voltage. Application: up to 1 kV, generally used for panel and distribution level, and 1 kV to 36 kV is substation level. Design type is single and three phase, and 1 kV to 36 kV single phase unit in WAG. And dielectric system is dry type polypropylene PP and oil and dry types for 1 to 36 kV. Testing standards: IC 60831 for LV capacitor and IC 60871 is for medium voltage capacitors. Protection: up to 1 kV internal resistor and medium voltage external fuse and relay. Okay, and installation for LV capacitor LT panel and medium voltage capacitor is frame of substation and structures. And now we are going to know design and construction of capacitors. Design parameters and materials. What is the component used in capacitor manufacturing? Dielectric film, material used PP, and function is high strength and low loss. Electrode is aluminum oblique zinc in conduction and self healing. Impregnant will be used in oil and gas and insulation for cooling. Case is the steel used for the mechanical strength. And register is for carbon and wire wound, and this is for energy discharge. Okay, electrical and configuration and standards. Capacitor connection methods: increase series connection, increase voltage capacity, while parallel connection enhance capacitance in capacitor design. Okay, For LV and MV capacitor design, series and parallel combination used for designing. Okay, and thermal and mechanical design is thermal design keep capacitor below 70 degrees Celsius using cooling and spacing, and mechanical design resist vibration and strength. And a standard and IC testing. A standard IC 60831 is for low voltage capacitor, and IC 60871 govern LV and MV capacitor with tested on dielectric strength, tolerance, and stability. Now, manufacturing and production process. Step by step manufacturing. Manufacturing process steps. Keep a step include inspection, winding, spraying, drying, impregnation, assembling, aging, testing, and packing for quality capacitor. Quality control tool. Quality check are done using micrometer, vacuum gauge, VDV testers, and 10 delta meter at every stage. Safety and environmental measures. High voltage safety protocols, while handling, PPE uses, grounding system ensure safe and eco-friendly operation, and manufacturing equipment. Essential equipment include winding machines, vacuum oven, oil impregation plant, and test bench. Okay, this is the manufacturing equipment: winding machine, vacuum oven, oil impregation plant, and test bench. In process quality control stage, film and foil. Parameters check is thickness and cleanliness. A tool use micrometers. Now a stage for winding. Parameter check alignment and tool use sensor. Drying. Parameter check moistures and tool use vacuum gas. Impregnation. Parameter check oil purity. Tool use BDB tester. Sealing. Leak test. Pressure kit. Testing procedure and instruments. Routine type and special test. Routine test overview. Routine test verify capacitor testings, compliance through visual inspection and measurement like capacitance and insulation resistance. Okay. And type testing characteristic. Type test evaluate capacitor thermal stability, over voltage endurance, and partial discharge, and short circuit extent for reliability assurance. Now, a special test and instrument. A special test include impulse voltage, sealing, thermal cycling, and vibration resistance using advanced instrument like PD tester, detector, and thermal cameras. Now, documentation and quality control. All test results are documented in QMS certified report ensuring compliance and traceability in capacitor manufacturing. Okay, this is the routine, type, and a special test. And this is the document and quality control. All test results are documented in QMS certified report ensuring compliance and traceability in capacitor manufacturing. Okay, now test setup and safety measures. High voltage test setup. Testing involve connecting capacitor to high voltage source and a specialized measuring device for various electrical tests. And types of electrical test is insulation, resistance, IR test, tan delta test, partial discharge test, with a standard voltage, imply specific equipment like mega tester and sharing bridge. And safety measure is safety protocol include earthing, interlocks, use of PPP, discharge procedure for protect operating during testing. And next is the document and procedure. Maintaining detailed test logs, calibration record, safety checklist is essential for reliability and compliance. Now, quality control and failure analysis. Common failure and root cause analysis. Common capacitor failure. Failure include dielectric breakdown, incorrect capacitance, and oil leakage, and PD failure and corrosion. Root cause identification. Root cause include poor materials, handling error, environmental factor identified through method like 5Y and 6N characters charts. And now corrective and preventive action. Kappa. Kappa is the action include involving drying, impregnation, welding, testing, calibration, predictive monitoring, and process improvement. Quality assurance and standard. QA follow ISO standards, include documentation of CAPA report and audit logs for continuous improvements. Quality assurance and documentation. Q and QC practices. Quality assurance include material inspection, in-process check, final testing, and through documentation. Now, a standard compliance ISO 19001, ISO 14001, and ISO 45001. A standards guide quality measurement and environmental safety. Documentation and traceability. Document like QAP, test log, batch record ensure traceability and quality accountability. Preventive and predictive actions. Preventive and predictive measure maintain quality consistency and compliance with IC standards. Now, production line and automation, workflow and equipment. Production line workflow. The workflow consists of multiple stages from raw material preparation to packing ensure a smooth operation. And key product equipment is film seater, winding machine, vacuum oven, and winding machine support various production steps. Next is automation and control. Automation uses PLC as oblique SCADA system for process control, data acquisition, and report generation, enhancing efficiency. Calibration and layout. Regular calibration ensures accuracy, linear factory layout minimize contamination and maximize workflow efficiency. Next is the calibration and maintenance. Regular instrument calibration is necessary for test labs and instruments such as capacitance meters, HV test set are calibrated regularly with traceable standard for accuracy. Comprehensive maintenance tasks. Maintenance involve cleaning, lubrication, alignment, leak check, sensor testing to ensure optimal equipment function. Preventive schedule and documentation. Define preventive schedule and detailed documents like calibration certificate ensure compliance with ISO and IC standards. Now, safety standards and compliance. Hazardous identification and PPE. Hazards in production. Identify process like film cutting, winding, soldering, and welding to ensure proper safety. Preventive safety measures use machine guards, interlocks, fume extractors, and pressure relief valve to prevent accident. Personal protective equipment. Wear insulating gloves, arc shield, upper clothing, safety shoes, and use earthing rod for protection. Safety procedure and compliance. Follow pre-test check, safe distance, discharge protocols, and common comply with IC, IS, and OSSA and ISO standards. Grounding and safety, fire safety. Grounding system component. Okay, first you ground the system component. Fire safety measures. Fire safety uses class B and C extinguisher and COD system. Safety documentation training. Provide the training to all the worker working on the test labs and electrician, technician, and engineers. Documents include safety checklist, PP inspection, fire drill records, and training plan for compliance. Certification and career opportunities. Documentation and accreditation. Certification required detailed QAP, test logs, NCR, CAPA reports, and safety audit to ensure quality and compliance. A standard and accreditation. ISO and IC standard guide documentation, while NABL accreditation demands qualified personnel's calibration instruments. Now, certification process. The certification process involve internal audits, application corrective action, and final assessment for compliance. Digital document management. Digital system enable document control, revision tracking, and ensure storage for efficient accreditation management. Career pathway and skills. Diverse career roles. Career opportunity include testings, QC, design, production, and service engineers across multiple industries. Industry employment. Key industries hiring include capacitor manufacturing, transfer OEM, power utilities, renewable energy, and testing labs. Okay, and essential skill like IC testing, HV test setup, data analysis, quality tools, ISO audit, CAD, and automation are critical. Professional certification. The course offer certification preparing learner for practical application and career growth in engineering field. Okay, so professional certification course offer certification preparing learner for practical application in career growth and engineering fields. Okay, so we have completed the all the course overview and some overview of all applications, safety, QQC, calibration, test logs, routine test, type test. Okay, so we will see next lecture. Thank you very much.